All right, dudes and dudesses, let's get into the Unreal Engine 4 experience. In other words, let's start programming. And in order to understand that, we need to first figure out what the framework is. In other words, how exactly does a game get made? Now, obviously, by now you should have an understanding about abstract programming and some ideas about, what functions are, what are different data types, etc. But there's a little bit more to it when it comes to Unreal, and I kind of wanted to go over this before we actually started creating our game, outright. So as you can see here, I've created this temporary project, and I really obviously don't intend to go over everything because frankly there's a lot of tutorials out there that give you a good rundown of everything. Honestly, by now you should have played with this. Not to mention that I'm not going to go over the same way as I did in Maya over all of these menus, because you see a lot of these different sort of blueprints, assets, in other words, I don't know what most of them do. Obviously, there's some that I have never actually used, like, for example, haptic feedback, a fed buffer that I suspect that has something to do with controllers. I never had to do that. Obviously, there's some, like in Paper 2D, I've never actually done a 2D game in Unreal Engine 4. I've only used Unity for that, so I have no idea how to work with that. I mean, I have an idea, I just never worked with this. Physics, of course, you will go over. Now, I'm no sound engineer, so I only know how to work with a few of these, not a lot of these, and I haven't made dialogue just yet, so I don't know how that system operates. But, the most important ones we will go over, at least in terms of their usability. Okay, now that being said, we should first jump into the draw.io, my favorite diagram sort of spot, where if I need a diagram, I just jump to draw.io and I quickly make this diagram. Now, what are you looking at? What do you have in front of you right now is sort of the game framework that we will be using. Now, the reason I have a server and a client here, and obviously we will be making a multiplayer game, but that will be much later in this video series. In fact, this will be in a patch where we will actually have the game will be released, and then we'll patch it up with the multiplayer support, just so that I can demonstrate how to patch stuff. And then we might make a DLC, although there's very little difference between DLC and patch release pipelines. Now, with that being said, let's just go over this really quick. Now, first of all, at the top, you'll notice that we have a game instance. And in fact, before I go further, I would first put your attention towards the server over here and the client. Now, of course, this is a very, wow, I didn't know you'd be typing inside the... Okay, can I just type this rightly? There we go. Now, currently we have a server and a client. Of course, this is going to be a very basic rundown of how networking works. This is definitely not an in-depth view, and I will not be explaining anything in this video about networking. I simply want you to understand a few things. That the reason why this framework is set up the way it is, okay? Now, first of all, we're going to start with game instance. Now, what is the game instance? By itself, it's essentially your overarching class, you could say an object, a container, that does not disappear, right? The moment your game gets created, the moment you start up your game, you get a game instance. Now, anything inside the game instance, whatever logic, data, anything that you store will persist until you shut down the game, all right? As such, it's by the way, these containers here, they're essentially, the reason they exist like that is so that you can figure out where you want to put your relevant data, all right? So imagine if we put it in game instance, and game instance disappeared every time, I don't know, every time you spawned something or every time you did something in the game, you would lose all the information inside the game instance. So game instance is sort of your spot where you will be storing a lot of the data that you want to transition between levels, for example, right? If your player if it's a single player game and you want your player to retain its the health, for example, because let's say in level 1 he had 100 health, and by default the player when spawned, the player gets 100 health. And if by the end of the level you load another level, assuming you don't stream anything, if you just do the classical load level, your player will be destroyed, and will everything in that level will be destroyed, including the game mode, everything except the game instance, and then will be transferred over to the next level. So if you want whatever you want to save between levels, you want to put that in the game instance class, because it is not destructible, of course, unless your game crashes or the power shuts down or something like that. Now, the reason I use the server and the client here is because some of these things can be replicated. Now, replication in layman's terms is basically synchronization between a server and a client. All right, now I'm going to make my server to be green, and my client will be red. So we want to be communicating between these two. Whenever you replicate something, you want to figure out when, let's say you want to replicate the health, right? So if the server says you should have 100 health, the client must know, yeah, I have 100 health. And then if something happens on the client, let's say you get shot, the client must say, hey dude, I just got shot. Look, please check how much damage I've been dealt, apply that to my health, and tell me what my health is. All right, that's basically how replication works. You have, let's say, the health variable, which is on the server, and the server gives information to the client so the client can display it to the player. Now, the important thing with replication is that it has to be sort of modular, right? You have to prevent access to the server, because this is your holy sort of spot where you judge and you execute rules and gameplay parameters, etc. All this stuff is being ran on the server, and then the client must only be viewing that. That is, of course, in the case of a multiplayer game. So if I drag this over from one side to another, like so, replication works only in this manner, right? This is the only fashion that replication works in. Okay, let's not do that. Let's just leave it as it is. So as you can see, you cannot actually replicate from the client to the server. That is not how it works, all right? The client only receives, it can request an update, it can request, give an event and say, dude, I just got shot, or hey man, I just moved from point A from point B, this is my trajectory, this is what I did, and the server says, yeah, that's legit, we acknowledge that, and that's it. Now the game instance runs, it does not get replicated, okay? You get an instance on the server, so the server has an instance, one instance, and the client has an instance, one instance. Okay, these two are not identical. All right, they're basically separate. Every server has its own game instance, every client has its own game instance. There is no replication between the two. I think these are not perfectly in distance, so we need to increase this distance like so. There we go. Make it nice. Ah, god damn it, man. Steady. All right, this looks much better, I believe. Now, what about the game mode? Well, the game mode only, in multiplayer games, of course, generally speaking, whenever you have a single player game, you will have your logic and pretty much everything really in the game mode. So the game mode only exists in the level itself. So as we go down, now the game instance is sort of like the warehouse where it's immovable. Everything in the game instance stays there until the game shuts down. The game mode is pretty much the same, except it's only for the level. So it's kind of smaller, all right? So this is not being replicated. I'm going to say that this is not replicated, and as such, I will say that it is orange, okay? The orange, keep it orange. So this is not replicated. The game mode itself is not replicated as well, but the difference is that the game mode only lives on the server, okay? It does not live on the client when we have multiplayer games, right? So whatever logic you put in game mode must be the utmost underlying rules of the gameplay, okay? That's not to say that you need to have a different game mode on every level. It could be the exact same game mode, however, it'll be reinitialized every time you start your level. Let's say in the game mode, we define that the amount of enemies on the level is 100, right? If the game mode persisted, once you kill 100 players and you load the next level, you will already be at the cap. Whereas whenever you destroy the game mode, it will be reinitialized with another set of enemies, which of course you can change depending on the level. Maybe second level will have 200 enemies, maybe the next one will have 300, etc., etc. Important thing is game mode only lives on the surface. I'm going to say that this is a green block here because it only lives on the server. Very important, very important. It prevents cheating. It means that the client cannot actually modify the game mode and say, hey, dude, such a speed hacks. There's a whole class of hacks, really. Speed hacks, aim hacks, damage hacks, bot hacks, any sort of bots. Well, bots are a little bit different, but all sorts of hacks are pretty much impossible because the client simply does not have access to this block of code which holds the logic, the most underlying rules, the responsible rules for this stuff. Now, after that, we have several other framework blocks. The first one is the game state. Now, the game state is basically taking information from the game mode and replicating it across the client. So whenever you have something, as far as I remember, game state is replicated, so it does as well communicate with the server, all right? So it does communicate with the server, and it also communicates with the client itself. This is starting to get difficult to perform. Right, so there we go. This is not good now. Come on. There we go. And there we go. Something like this. So as you can see, the game state is replicated across all of them. It receives data from the game mode, which resides on the server. Okay, so the game mode is on the server, it sends information to the game state, and the game state is replicated between all of them. Now, replicated stuff we will make blue. Okay, this is replicated. Same goes for player state. Now, the player state is also replicated. Generally speaking, a game state is responsible for all the information inside the current level. Okay, relevant to the level. How much enemies there are. What kind of AI do we have? Does it move left and right? How many times the player, well, not the player, how many, let's say, I don't know, like game-wide events, right? Such as volcanoes erupting, I don't know, whatever you got there. Skills working correctly, right? That kind of stuff. Although game state is more of a data holder. The way that logic is executed in a multiplayer game, you want most of it to be ran by the game mode. So that however many, the more logic you have on the game mode, that means the safer your code is from tampering, because it is only available on the server. Okay, unless of course your server gets hacked, then you're screwed. So the player state is much like the game state, but it only responds to it only responds to the player specific stuff. So the player state also holds things. It is also replicated between the two. So the player state is replicated between the server. Server has knowledge of the player state, like so, maybe something like this. And it also the client. The client actually is one of the main feeders of the player state, because it gives its information, right? So the client gives info to the server, says to the player state, be like, hey dude, yeah, we got this, we got that. Generally speaking, you might want to be, I don't know, like player score. You see, the cool thing about player state is that it basically exists as long as the player exists in the game. Okay. In other words, as long as the player itself exists, right? Now, after that, we've got the controller subset of classes, the AI controller and the player controller. The player controller is essentially your keyboard and mouse. This is the stuff, or whatever, joystick, joypad. So the player controller generally is, if I remember correctly, and I'm not sure about that, I don't think it's replicated. I think the player controller is, I mean, it's basically... I mean, you can replicate it, definitely, but it's just mostly on the client side, right? This is the stuff that, like, the client, the server doesn't need to know if you jump with spacebar or with control or with enter or whatever. So it's mostly client-based. I'm just gonna say that it's red. I know I'm pretty sure it can be replicated. I'm just not 100% sure if it could be, there really isn't a lot of need, I think, to replicate it, at least in a good setup. Obviously, you could, but then what's the point? So I'm going to say that it talks mostly with the client. Doesn't mean that you cannot replicate it. Again, a lot of the stuff can be replicated onto the server. Just because I say it's read for the client means that you better use it for the client only. Now, the client side, the player controller, you can still store stuff here, right? Generally speaking, in the player controller, you will handle your control subset. The cool bit is you could swap them out. So if you have a tank and if you have a plane and a helicopter and like a character, you can actually have a separate controller for each of those things. That's why you might want to be storing relevant information in your player state, meaning that, let's say, the score and the health, well, not the health, but maybe the health too, I don't know, the score, all that stuff you might want to store in the player state. Obviously, it depends if you're running multiplayer or not. If you're running multiplayer, you might want to store it in player state, but make it governed by the game mode. Whereas in a single player game, that really doesn't matter much, because the single player, the first player is also the server, so it doesn't matter. You can store everything in player state if you want to. You don't necessarily need game state. In fact, in single player, even in our game, we probably will end up using game mode, although if we make a server, we might transition that into a game state. I'm not sure what we're going to do yet, but that's a ways to go. So here's our game state, player controller. Player controller is destructible as well. So like I said, if you swap it out, let's say you jump from a bike onto a car, you still want to retain some of the important information that is that is required for running. Now, generally speaking, player controller does update player state. You can update player state, but player state is the more persistent one. All right. AI controller, on the other hand, is generally useful. Like, generally speaking, it only runs on the server. I mean, definitely you can run it on the client, but most of the time you will want your AI to run on the server. The client does not need to know a dime, like anything, right? The AI does what it does, and the client shouldn't be the wiser about it. So I'm going to say that the AI controller is only responsible for server. Generally speaking, yes, you can replicate between the two, I believe, but there really is no point, again, because the AI controller is responsible for things that challenge the player, and if the player has access to it and is able to change it, right, that's a problem. I do think you can run AI controllers on the client as well, though. Just don't take my word for it. Like I said, networking is a little bit more complicated, and I'm not 100% sure how the approach, like I think very few people actually know how the framework works exactly. In fact, Googling this stuff is pretty difficult. There's a really nice PDF document there which explains a lot of networking stuff by EXE, I think, or whatever his name is. The dude did a really good job. It's a marvelous compendium. I think it's called UE4 Networking Compendium or whatever. Good stuff there. Read it. Now, the HUD itself. Now, the HUD is a deprecated leftover class from the old days of Unreal. In other words, you don't have to use it. Okay, it generally, a lot of the stuff, especially game HUD related, GUI related, you could run on the player state, on the game mode if in a single player game, or in the game instance itself, or on the player controller, right? Whatever you decide. Obviously, slap your data where you feel it's appropriate. For example, you don't want to put it in the player controller if you're going to lose your player pretty quickly, right? If you're going to change, like, for example, it's nice to have it if you have player controller for your tank, player controller for your car, and a player controller for your character, and all of these have different HUD setups. So you can simply say, right, my player controller is going to have this setup. Sorry, my tank will have this kind of UI. My car is going to have this kind of UI, and of course, like, you don't need a speedometer or an odometer or whatever. You don't need to check your speed when you're running, like when you're running with a character, right? You don't have revolutions per minute on your legs. Well, you do, but it's pointless. That's why you might want to do that on the player controller, or again, you could do that on the HUD. It's fairly simple to swap the HUD out, just like you do with the player controller. I do think that it is replicatable. I'm not sure I'm going to put this gray because I'm not sure exactly what HUD does. Like, it's kind of like a catch-all term. You can put whatever you want with it in it, and I do think it's replicated. You can replicate it. Yeah, actually. No, my bad. You cannot replicate it. I'm pretty sure you can't replicate that. Yeah. So it's only server side. It's only client side. My bad. So the HUD is only client side, and basically you can store in it whatever you want because it does persist throughout levels as well. Actually, no, it doesn't. It only game instance persists throughout levels. But the point is that you can use quite a lot of stuff on the HUD on its own. So basically, depending on what you want to do, put the logic where you think it's appropriate. Then you've got your object. Now, the object is the governing uppermost class. By the way, from here on out, everything can be replicated with varying success. So I'm not going to color code this the same way I did these master superclasses. And generally speaking, these will be ran, you can run them anywhere. You know, these are classes that can be ran on anything. So first of all, we've got the object / actor component. The reason I'm saying actor component is because object is actually not accessible in Unreal Engine 4. The only way to access it is to use an actor component. This is the biggest, most generic wrapping object that you can have, all right? Anything really is an object. Afterwards, you have a actor. Now, the actor inherits directly from the object. Because the object is very generic, there really isn't that much to inherit. But the actor is sort of anything that you can place in Unreal Engine 4. Don't let the name confuse you, because actors are everything. Lights are actors, tables are actors, players are actors, bikes are actors, benches are actors, pebbles are actors. Everything you see on your screen, every object, anything, it doesn't have to be even visible, okay, is an actor. All right, so just put it to your head, like an actor, anything. Really, I think they should have just named it object, because actor is very confusing. It implies something that is movable, that's moving and is alive, whereas in reality it's simply an object. It's a catch-all term for anything you find. After that, you've got a pawn, which inherits directly from the actor and is a type of thing that can be possessed. Now, the cool bit about possession is that it can be possessed by either the AI, okay, or the player controller. So a pawn can be possessed either by the AI or the player controller. By the way, the same applies for the character. So I'm going to just grab another bit here just so that we save ourselves some time for the future. Okay, now the pawn, the difference between the pawn and the character, I hope you already figured it out that the character is inheriting from the pawn. And these are both, of course, possessible. You can possess these. So what does possession first of all mean? It means that whenever a player controller is assigned to a pawn, in other words, possesses it, whatever input you give it, because the player controller or AI controller, whatever input is given to the pawn, it will respond to it, all right? This is your mediator between the keyboard and the results, your avatar, all right? So the player controller is actually the player, in other words, you, and the pawn is the executor of the command. So this is the brain, this is the brawn. Whatever it is you give, whatever command you give, as long as the pawn has the appropriate logic in it, it will execute based on that logic without fail. Of course, the pawn will operate based on these rules. So whatever you have defined in the game instance or the game mode, you can imagine the game mode as your judge, as a judge in a court, and your game state as your translator, because the judge speaks in this ancient language, all right, whatever. Nobody understands what the judge says. Nobody knows what the judge is. Nobody even sees him. So the game state is the representative of your judge, and the game instance is kind of like the courtroom itself. So just think of it this way. And obviously, the pawns and the characters and the actors, they're kind of like the spectators or the advocates or whatever floats your boat, like whoever is inside the actual court, right? Now, the pawn itself, of course, is kind of limited in terms of its integrated built-in functionality. In that, yes, it can be possessed by an AI controller or a player controller, but generally the pawn is not very receptive to, it's not very easy to work with, all right? Just put it this way. Unlike a character, which I believe is not actually aligned. Yes, there we go. Now it's aligned. Now, a character has a built-in system for movement, jumps, flying. Basically, a character is anything humanoid that is capable of traversing. Not even humanoid. I think you can define a character even as four-legged creatures. Anything that has any resemblance of a biped, a quadruped that moves with a walking animation. Just put it this way. So the difference between a pawn and a character is that character has movement components on it, and all sorts of other good stuff, essentially, that allows you to sort of much easier perform the execute the commands of the player or the AI for that matter. Generally speaking, though, you might want to figure out which you want to be using for. Generally, you would have a separate character for the AI. You wouldn't want to have your player controller possessing the AI and vice versa. Although it's definitely possible, it's just a pain in the ass to implement because it needs two separate control sets. Now, the pawn and the character are the two basic possessive actors, so to speak. And the difference between them is that the pawn is sort of like your overall movement container. So the pawn would be, let's say, a tank, right? A car, or anything that is not walking but has to move. You have to define the rules yourself. A plane would be a pawn. A car would be a pawn. If a player uses a glider, then it will become a pawn. The glider will be a pawn because the player is, it doesn't walk anymore. So even though the player controller is controlling the character, once, let's say, you grab a glider, you will be controlling the glider and the character will be just along for the ride. You will disconnect the character controls. You will essentially change the controller type to the pawn, right? The player wouldn't be the wiser because, how the fuck would he know what happened? But essentially you do. And once the player disengages, you will swap the control set back to a character control set and the game will continue. Of course, if you have your HUD or your widgets or whatever UI on your player controller, you will also swap that along with the control set. Now, of course, there's other sort of actors, other offshoots of the actor, plenty in fact, and all of these are kind of like the parent classes. All of these have derivatives, inherited classes, loads and loads of stuff. The HUD is like the only thing that kind of just exists. I don't know if anyone uses it for anything. I do like to put my UI here. Unfortunately, of course, it means that if I want to swap out, for example, the UI, I need to swap out the player controller and the UI itself. In other words, I have to swap these two for a different version whenever I want to do something separately. However, I think it's a nice container for all your widget logic, allowing you to kind of, folderize it. Or look, whenever you talk about your graphic user interface, you're thinking about the HUD, right? The heads-up display. So you're thinking, yeah, if that's where I'm going to look for it. You're not going to look for it in player controller where you have everything set up. Oh, space is going to jump, enter is going to fire, whatever. And then you got to look all over the place and find the freaking viewports and whatever it is you set up for your widgets. And if they have to pass data, somewhere, then it just gets kind of ridiculous, I think. Obviously, depending on the scale of your project, you might do everything in a game mode. Like I've done a pretty ridiculous game. It's just an idiotic game. It's a parody. Well, I don't know. I think it's a satire of the current game industry, but it was basically a ball that had to travel for, like, the gameplay time. If you wanted to beat the game, you had to like go straight for 666 hours. And I did something ridiculous, like if you just lock your key and it would start blowing wind left and right, you just fall off of the plank or whatever it is you were driving along, and you'd lose. So you wouldn't be able to cheat your way in, so to speak. But of course, it's obviously cheatable since it's not it's not run on a server, right? That's kind of like an off topic. But the point is that depending on the size of the game, in this example that I gave you, I did everything in the game mode because who gives a shit, right? But in general, you do want to compartmentalize in such a way that your data is easily accessible between different blocks, right? And also that your data is protected in terms of the game mode. You want it to be safe inside the server. If it's a single player game, there really is nothing you can do about it. If people want to cheat, they will cheat. However, server, client, much more difficult to cheat. And of course, then you want to have, for organizational purposes, it's just a much better flow, I think, when it comes to your game. Now, that being said, this is essentially everything I wanted to use the Draw.io for, so I'm just going to minimize this. I do want to save that. And we will go over here and just take a look at the same things I just explained. If we take a look at the world settings here, you'll quickly see that we have game mode. Now, of course, currently we're using the default game mode, which can be accessed if we edit the project settings. And over here in the project settings, if we go to gameplay, maps and modes, you will see that our default game mode is game mode base. Obviously, there's some others such as functional test game. I don't know what that is even for. And of course, you can change these default settings as well. Of course, you got your default maps here. We already went over this stuff in the other, like in the beginning of this whole series, so there really isn't no need to go over them again. However, we will visit this one more time in the very near future because we will we'll change the game mode here to our custom game mode. We'll change the default pawn class, the HUD class, the player controller class, the etc., the etc., the etc., and the etc. Basically, all of these will be redefined because we will be storing, presumably, data on them. Now, how do we, at first, of course, you have to figure out how do we create a blueprint. Now, a blueprint is, how long has it been by this? I think it's been a fairly long video. Should we perhaps split this up? Yes, so I'm gonna just finish the framework here, and then I'll talk about blueprints and functions and data types and flow control, etc. in another video. Let's finish this here really quick. So first of all, we need to create a blueprint class because, of course, everything is a blueprint in Unreal Engine 4. This is a blueprint. This is a blueprint. This is a blueprint. Everything is a blueprint, right? There we go. We can actually change this. Well, in this case, we need to create a blueprint, but currently, of course, it's a static mesh. But if something has a blueprint, I don't know. Is there anything here that can that has a blueprint, has some kind of interactivity? No, unfortunately not. I believe we need to change the levels here. We go to advanced lighting. Let's say no, starter map. I think this is a much more advanced. Yeah, there's definitely blueprints here. Gonna have to wait for some shaders to get compiled, but there's definitely some more stuff to do here. So if we go ahead and take a look, for example, here, you will see that we've got audio. So I'm just going to edit this blueprint. It will take some time to edit. Take a look at the viewport, and there is our blueprint. So everything is a blueprint. I really need to slow down my camera speed, but I'm not going to do that just yet. Okay, that being said, we should now go ahead and take a look at the game mode itself. Obviously, if you don't have the world settings here, you can always go to the settings here and just click world settings. That being said, currently, as you can see, our game mode override is none. The reason it says override, of course, is because we'll be overriding the base game. By the way, the forward and backwards keys work marvelously. If you have a mouse with forward and backwards, I highly recommend that for you if you want to use. Of course, here you can import all loads of different stuff. But for now, we will simply create a regular blueprint class. And here you will see that we've got the same things that we had previously. Of course, you can click this for the documentation, or you can hold Control and Alt for further explanation about what it is. So in this case, as you can see, a pawn is a subclass of actor that serves as an in-game avatar or persona, such as the characters in the game. Pawns can be controlled by a player or by the game's AI, such as the case of non-player characters. All right. The point of a pawn, of course, is that it's not a good. As you can see, the character is a type of pawn that includes the ability to walk around. So first of all, let's create an actor. I'm going to call this actor. Now I'm going to create another one. I'm going to call this pawn. I'm going to create another one. I'm going to call this character. And another one. I'm going to call this player controller. And here I'm going to call another one and say that this is a game mode. And of course, I'm going to create another one called, obviously, whatever you don't see here, you just expand all classes and search for whatever it is you need. I'm currently, of course, in need of a HUD class. So there's my HUD. Create one, HUD, and another one. We need, of course, a pawn class, default pawn class. I believe it is possible to set it here because this could be our default pawn class. Let me see, pawn. Yes, we will use this one, and we'll also use player controller. Well, you have a player controller. What is all right? It's game state. Yeah, state. Game state base. Of course, you can take another game state here, but I'm just gonna use the default one, the base one. Of course, you could use the other one, which is like the multiplayer, like the defined one. That's just the base class. Another blueprint class. This will be, oh, there's a spectator class. I didn't even know that. There's gonna be player state, and there it is, player state class. And then, of course, we need spectator. Let's just design a spectator as well. What? Is that what it is? Spectator pawn? I don't know. Let's take a look. Let's see what this happens. Spectator. Now, so now that we have all of these, of course, we should save. You should always save. Mark my words, always save. Now that we have all of these, we could assign them to the world, all right? First of all, we need to create a game mode. So currently our game mode is, god damn it. Let me just rename this real quick. Is there a quick way to rename stuff? F2, okay, F2. Game mode EX, which is gonna be kind of like, I wonder if I can rename these at the same time. No, I cannot. That's quite unfortunate. EX, basically, for example, EX, for example, EX, for example, EX, for example, and of course, EX, for example. And then we got character, EX, and actor, EX. Okay. Although actor doesn't matter because we're not going to be replacing the actor. Let's take a look now what we have here. Game mode, and if we take a look, we've got our game mode EX. Now game mode EX has its default setup. Currently we're using default pawn, but we can use pawn EX as our default pawn. HUD EX is our default HUD. Player controller EX is default player controller. Game state, player state, and of course spectator. So what exactly did we do here right now? Well, currently we've assigned everything here to this game mode. So if I go ahead and save and I change the game mode now to regular game mode, you'll see that the default stuff is just removed, right? If I go ahead and change this to game mode base or regular game mode, it's just that's the way it is. Functional test game mode, I have no idea what this does. How is that different in any way? But then if I go back to game EX, I've got all of my parameters, all of my extra classes defined here. So changing the game mode, you can literally change everything about your game with one click of a button, as long as, of course, you have it defined. All right. One more thing. Now you can shut off this video because we're kind of done with what I wanted to go over, at least in this, at least for now. But there's one more thing I want you to take a look at if you're just inclined to stay for a little bit longer. So if we take a look here on this side, we've got ourselves I believe, view options. This will take a while because it's been a while since I've done this. Let me just see here. I think filters. We need to use filters, and we need to use. Let me see here. Basically, you have to clean out, you have to run some cleanup here. There we go, show redirectors. That's what you want to see. Now, currently, of course, we don't have any, but if I go ahead and create a new folder and I move these guys, this should create a set of redirectors. No? Ah, yeah, that's because there we go, we've got a redirector. Now, you see, this redirector essentially means that it's kind of like a shortcut, right? Whenever it's like a shortcut on your desktop. These redirectors can really bog your sort of project, and just keep adding and moving stuff around in your thing. You do want to delete these. There was a way to clear redirectors. I just don't know what was the way to do that, actually. Right, so I'm gonna stop the video here. I'm gonna go check how it was. Obviously, you can just delete it by hand. There we go, delete by hand, and you should be able to delete everything by hand. But I do want to check how to clean up the whole thing. I think it was possible to simply right click here and say fix up redirectors and folder. There we go. This should fix them all up. Okay, there we go. It's coming back to me. It's coming back to me. It's been a while since I've done that because kind of a lot of times I spend a lot of time on Maya and Paint and all that crap, and just I do like Unreal Engine 4 a lot more. It's just that I kind of had to forget about a few things, right? Anyway, I'll see you guys next time. Obviously, just click this to remove the show filters. You can just remove the actual filter on its own. And I'll see you next time when we just go over the blueprints themselves. All right? Cool. Bye-bye.